Welcome to this tutorial. I'm solving question number 3 of GCSE O Level Physics paper 2 to October-November exam series of 2017. The question says a solid rectangular concrete block is lying horizontal on flat ground with one of its largest sides in contact with the ground. So the side which is in contact with the ground is this one. Figure 3.1 shows the dimensions of the block. So we have the length, the width, and the height of the block. The weight of the block is 240 newtons. Calculate the pressure on the ground caused by the block. So the pressure is given by the formula force per unit area, the normal force per unit area. The force caused by the block would be equal to the weight of the block, and the area would be the area of this face which is in contact with the ground, and it is a rectangular face, so the area would be the product of its length and the width. So force divided by the area would give us the pressure, and it is 2.6 into 10 raised to 3 pascals if represented in two significant figures and in the um, standard form. The next part says state why the total pressure on the ground underneath the block is larger than the value obtained in part A. So the reason is the value we calculated was the value of the pressure caused by the block itself, and additionally atmospheric pressure is also acting on the block, which is causing extra amount of pressure which was not included in the previous part calculation. The block is of uniform density. State the height of the center of mass of the block above the ground. So in this position, the center of mass would be halfway as compared to the height given to us. So for this, we would be taking half of this height value, and it would come out to be 0.065 meters. So the value of height of center of mass is 0.065 meters. Since it is a regular shaped block, so the center of mass would be in the center, and if we talk about the length, it would be at the center of this length. If we talk about the width wise, it would be at the center, and if we talk about the height of the block, then the height wise it would also be at the central point. For that, we have to halve this value of the height given to us. The next part says the block is rotated about its lower left hand edge. So this is the way the block is being rotated, so that it comes to rest when on one of its smallest sides. This is shown in figure 3.2. Explain why work is done as the block is rotated. So for the rotation of the block, we know that block has weight, and a force is exerted on the block to make it rotate against the gravity. The force of gravity is acting on the block, and we are trying to rotate it against the gravity. So work is done. Since we are moving the block against the gravity, and it is gaining gravitational potential energy, its center of mass is raising, so the work is done. As the center of mass rises. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.